Hola a todos, bienvenidos. Y nada, quería compartir este vídeo con vosotros ya que me estoy preparando para una presentación de mi club de ciberseguridad de estudiantes presentaré sobre pentesting, que pentesting vamos a ver es como hackear de forma éticamente a una compañía, en este caso a una planta industrial, que es donde viene la diversión, porque es donde se ve más físicamente, algo puede pasar muy malo. Y estoy bromeando cuando digo diversión. Es un poco de sarcasmo. Pero bueno, ya nada, quería presentar, practicar mi comunicación como todos estamos aquí practicando. Y nada, espero que os guste. Y nada, lo voy a hacer en inglés, así que perdonad a aquellos que no habláis inglés. Pero la presentación en inglés, así que me vendría bien practicarla en inglés y no en español. Que igualmente da igual, pero bueno, me parece mejor, al menos me ayuda más si lo hago en inglés. Así que espero que os guste y nada, empecemos. Hi everyone, welcome to the industrial cybersecurity presentation. Today we'll be speaking about introduction to ICS pen testing. For those that are not really aware of what ICS means, it stands for Industrial Control Systems, and pen testing, for those that don't know this activity, what this activity is about. Pen testing is the activity that normally some ethical hackers will go to a company or somewhere and will try to break the system to whatever the company requires are and following their rules. Again, this is ethical and is nothing illegal. And normally these people will have previous approved or contract by the company that they're attacking. And once they have that, they have this thing called the wild card or white card that they can show at any time that they will free them from jail, because of course this activity will be really legal if it's not done with previous approval. So this card allows them to do this legally because that's their job. So my name is Ignacio Giralta Perez. I'm the president of the cybersecurity student class here at Yahoo University, and let's go with this presentation. Okay, so first, let's go through the points that we're going to be touching today. So number one, we're going to go through what ICS is. As I mentioned in the is Industrial Control Systems. Maybe some of you don't know what this is. We have presented in the past. We have speakers coming on other presentations, but in case there is anyone new, we can go through this today. As well, for point number two, we'll be looking at ICS threat landscape. We will be going and seeing what can be done in industrial control systems, as is nothing similar to what an IT system could be. Number three would be ICS versus IT. As I just mentioned before, these systems may run and communicate similarly, well, not really, but people may believe that cybersecurity is applied the same in every system, and that's not the case. And in this point, we're going to be focusing more on the pen testing portion, because the systems are not running the same. How do we attack them differently? Do we want to break a nuclear plant if I'm just trying to prove a company that hired me to show them that they can be hackable, that the plant is exploded? So when the plant explodes, I mean, it does really, really bad. I'm just giving a really bad example, but that cannot be done. So what we can do as an ICS professional in pen testing in this case. And then number point four, we're going to be going through some ICS pen testing tools, where it's opening up there, and what we can do with those. And then for number five, we're going to be doing a workshop today. Hopefully we have enough time. We only have an hour for this presentation and this meeting, so maybe in this case I will have a lot of resources too, in case that we run out of time by number five. Okay, so let's start with this. Perfect. So what is ICS? So ICS, as I mentioned earlier, is industrial control systems and are hardware and software systems that monitor and control physical processes. So let's say that you love potatoes, like potato chips, right? So if you go to the store, you already have a bucket, like you have already in the bag, you already have it fried, sliced, salted, spice, and everything that has to go through it, right? Like the potatoes, we know we start in a process. So you have the agricultural process. Majority of these processes are done by hand, but within the time they're even done more as with automation, because automation is cheaper than hand labor, really, in reality. So more here in Idaho. We really love potato, and we still do it a lot by hand, but within the time we're going to see that change. So ICS applies there. Then you have the transportation. Majority of the things is more IT, cybersecurity, but within the time with the new Tesla trucks, there you go. It's all automated again. So there you have more ICS. Then you have the plant that processes the potatoes and converts them into chips, bags them, and everything I mentioned earlier. All that is automated for the most part. Of course, there is some hard labor in the line of the process, but you have all that there. And as I mentioned here, there is more than potato chips. We have energy systems, we have manufacturer, as we just talked about, we have transportation as well, and utilities. This could be a water treatment plant. These have been attacked recently in the United States, and they have been seeing that the threat actors have been sitting there for a lot of time. In this point in the presentation, I will be asking why you think so, and I will be expecting a response and working with the people. So I'm not going to respond myself here, but that would be because the threat actors, in this case supposedly China, has been sitting in these systems for so long that these systems are being used now for the war. If the United States get in any war where China is implicated, China could just go to their computer and say, okay, water treatment of your plant off, you don't have clean water. And these attacks may be hard to fix because you have the physical portion, you have the virtual portion, so this is really hard, and it could be used for damage a lot of communities, cities, and countries. So key components of ICS. PLCs. So a PLC is a programmable logic controller. This device controls the machinery. Literally, you have a sensor that controls, that activates something, just to make it simple. So every time a potato passes, it will control the time between them, and it will sort them out so the next machine can handle it better. Let's say that, right? So that sensor will be connecting directly to the PLC, but the PLC are interconnected. So that next machine that will perfectly need it separately so it can cut it out, or whatever action it needs to do. All these are connected. So PLCs are really important. These are the ones that you can program, and then you can hardwire to those devices into the plant. Then you have RTUs, remote terminal unit. These collect data from the sensors and release command. Some of these are used in some plants, not every plant. Majority of big plants, of course, they have these ones. SCADA system, supervisory control and data acquisition, oversees large scale processes. In a big plant, you have a lot of PLCs, RTUs, and other components within the ICS systems, and then you need to have a SCADA. SCADA collects all the data, puts together, and then you have a monitor where you can see a map that you program and configure, and then you can with that you can have all the information in your face. You can see what is the temperature, what is the speed, what is going on. So normally the people are in really bad, in medium and large plants, and they always have a control room where the control people have their SCADA systems in front of them, and in case something happen, they're the ones that work it out with the people in the field, and they communicate with each other to fix that error. And then you have a HMI, a human machine interface. These are normally set within the field and allows human operators to interact with the ICS. This, imagine your SCADA. SCADA could be all the plan or a full process of one full batch, say that. So a HMI could be one portion of that batch. So let's say for the potatoes, I just add the washer. So the machine that was the potatoes and sort them out, let's say that, is only one HMI. So that HMI, if I'm a field technician, I will be checking that HMI every other time, and it will be the one that I will go to troubleshoot anything. And it's here. And here I have a little big picture for you guys, so it's easier to see. So this is a PLC, it's a hardware device. You'll be connecting the field devices right here into these portions over here, and then I think this is a RTU, and of course all these can look different. So in this case, I'm kind of confused, but I think this is the RTU right here, and you'll be connecting this over here, and then this you will be connecting them to the HMI. You can do that. So that's a little plant thing. So it's a little screen that you can screen touch that you can play with, play as, take information from them, troubleshoot. They will help you to troubleshoot whatever you're trying to find within the plan, and then all this will be connecting to SCADA servers. This, of course, there is a lot of data that happens within seconds, so all this need to be collected. SQL database server, sure. If you have if you need to pull this into the internet so it can be remotely, of course, with a nuclear plant, maybe you don't want something remotely to be connected, or maybe you do. So it really depends, but you can have that as well. And then you have the engineer station. This is normally what I was saying earlier. The control room will have this, and it will be an engineer workstation, normal computer that gets the programs limitation, and we will talk about this later. But you have it right there. And then clients, as I say, do you have more than one people that need to see this? Maybe yes, maybe not. So it will depend a lot depending on the plan, but this is a really good, simple, and easy to view to give a more understanding of what we talk about. Okay, so let's go with the second portion. So ICS architecture and communication protocols. So ICS systems have different architecture from typical IT environments. So levels of control. You have the field devices, control devices, and supervisory systems. So as we saw earlier, you have the field devices, the control devices, and the supervisory systems. Okay, so ICS protocols such as Modbus, DMP3, or OPC are different from traditional IT protocols like TCP/IP. Okay, so these depending on what device you use. Each device uses its own protocol as well as in the IT. A speaker maybe using a similar protocol, but maybe different depending on what brand you're using. Same thing with this. Every brand normally try to run similar ones, but may depend between the most general ones between what brand you use. So challenge for ICS security. You have real-time constraints, like it has to happen. So many of you that are cybersecurity majors, and again, I'm going to go here, majority of our members are cybersecurity majors. If not, I will go more in depth if there is any that doesn't know this, but there is the CIA triad. So that means confidentiality, integrity, and availability. Okay. So in cybersecurity, we don't care about our data that much if not our plan keeps running. That's what I care. As the owner of a plant or owner of this brand that makes these chips, potato chips, I want the plant to keep running. If I don't run for a couple hours, I'm losing money. I can get in trouble with policies. So system longevity. I'm not going to be changing my system every other month. I'm not going to be updating systems that I don't know if my all field devices, control devices can take. I don't know that, but majority of them don't. So while I'll be updating, while we'll be changing these devices, I don't have the time because all the mining takes a lot of time, and that time costs me a lot of money. So limited security measures, and this is due to legacy systems. So there is a lot of systems that within a time they lose security and they lose support. As we saw before, that's because the system longevity normally often 2 decades old. So that's a really big portion to understand for IC architecture. That changes things a lot for the view of a pen tester, in this case for this presentation. Okay, so here I have the Purdue model, okay? This is how things are connected as networking communication goes. So here you have the different communications that you will be using for this, okay? So you have the device, I guess you could call this by the Purdue model. You have 5 levels, and each level has its own name. You have level 0, which are the field devices that we saw earlier. So these devices, for example, here we have a valve. I think this is another valve right here, different one. All these are valves. That's a tank. I think maybe that's a sensor. Actually, that's a sensor that goes down, and I think you use some kind of waves. Like it depends on what system you're using, but I use waves to detect how full it is. We can give you some other information. Okay, So you have two PLCs. I think this is RTU, as I said earlier, but from this picture I cannot tell. I know for sure this is a PLC, and these are network switches. Network switches, all of you may know what it is, but it's used in the network, like for any IT system that you use typically to. You enter. It helps you to have a large connection to different processes and separate if you want to. Okay, so you have your local HMIs. We saw those early. Here are shown as computers. They could be computers too. They don't need to be touch screens. A screen as we saw earlier. You have another switch. For here you have a firewall, and then you have your operation admin. And you guys can go through this, but your operation admin. This is an important one. You have your historian, keeps all the information, domain controller, AVA servers, and other third-party apps. Okay. So do we want? And let's keep going up. Let's go. You have our firewall, switch, and then you got Antivirus server, enterprise desktops. So like the people that are doing the numbers or other stuff that is important too for a big company to do, right? Internal database and file services, email services, web service, internet. Okay. Do you want, I don't know, Bob in sales department to be talking to this valve? Maybe not, right? That shouldn't be the case. So why these devices and this portion right here shouldn't be talking to anything really out there in the network, in the internet, or within any other laptop or computer that can be talking to the internet? That's really important. Okay, it's a really good map. There is really a lot of Purdue models out there, maps for different views and perspectives that are really cool. So if you guys have the chance, I would recommend to look those out. This is the typical industrial network architecture Purdue model, but this is a really simple one. There is more complete ones. Okay, so threat landscape in ICS. So I'm going to give you a couple examples. We have a selection in 2010. This was a malware that was targeting PLCs in Iran's nuclear facility, and this altered the physical processes. This device had different eras, to say different processes, different versions. So for each different version, it did something different. But this directly attack. There is a lot of information out there and really good videos. If you have had the chance, there's a lot of good documentaries out there, and I would recommend all of you to look this up. But there is different views and histories, of course. But Stacknet, for the most part, attack, the most popular one, attack the BFDs, variable frequency driver, I think, BFD, my bad. So VFD is a device that controls a motor and the speed, the frequency of it. So depending on the frequency, the motor will spin to different speed, right? So that was a big thing, and it messed up a lot of the plants. The bad thing of this is that they got really wet with cybersecurity, within ICS cybersecurity. Then we have the Ukraine power grid attack on a SCADA system that caused a large scale of blackout. This is a really popular one. If you guys haven't read Sandworm, the book, they have it on ebook option as well as audiobook. A really good book for ICS systems. So I would recommend you all to look at it. And then you have Triton, Trices. I have only heard about Triton before. It's the first time I when I was looking at about Trices. This was in 2017, and it was a malware that target safety systems in petroleum plants. A safety system is a system that is programmed. Let's say that I don't want this tank that has this liquid shouldn't go over this pressure. Okay, so if this tank goes over this pressure, what is going to happen? Maybe kaboom. Whatever happens, do you have something out there that helps you out? Well, there is systems that you can program, so they have a sensor connector, and if something goes bad, there is a process that needs to happen that you will create and configure, so something happens, so this doesn't happen. If I have a tank and I'm attacking it, and I wanted the pressure to go up, maybe I didn't know that there was a safety system within it, and now because that was in there is a valve that lets air out. But all this is done digitally by sensors information, right? Well, you can attack that. because it's connected. You can program, you can configure it, you can change it. So what they did, they attacked those, changing it. So when that attacked, the safety system didn't activate it. And if I remember correctly, there was explosion, if I remember correctly, for this specific attack. So common ICS vulnerabilities. Then you have outdated systems, as we talked earlier, and they're unpatched, because maybe if you patch it, it will be bad for your system. You have weak network segmentation. Not many people segment their network really well for the OT and IT networks. As we saw earlier, we have a lot of segmentation here. You should have a DMC area that is not being shown here because it's a really simple network map. Then you have use of default or weak passwords in control system. I get this device that is the control system, or yeah, it's my HMI, for example, my local HMI, this local HMI, by some chance I didn't look into it, and this local HMI can be connected to the internet, and then I can do actions through that connection. But I didn't know that because I'm the technician and I don't read the manual. I just know the basics. I know what I've been taught, so I just connect the stuff. It works perfect. As an attacker, I will check that stuff. I will look what device you have. I will investigate. Once I have the information, I can use the information to attack it. If you didn't close that connectivity to the internet, I can go and check in the manual what the default password for that specific device is. Some companies now, they do different passwords, so that's good. But because we're talking about outdated systems, majority of the passwords before were the same for all the devices that they will sell. So I will go and I will be password. The password of the password is password. So I will go and put password and connect directly, and I have access to it. So here I have a couple videos, okay? So there is this video. Maybe it will work, maybe it won't. Let's see. Oh, maybe it's because I had the laser. So let me take this out. Okay. So I'm going to play this video. So this is the Aurora project, okay? The Aurora project was done by different people, but majority was done here in INL and the Department of Homeland Security. This was done in 2007, a long time ago. So I would say that industrial cybersecurity has been happening now for, it has been happening now for a couple, I will say since the 2000s, like late 1990s and early 2000s. That's where I will say that everything started. And with the time, it's more interconnection with everything. So that's why it's so important. So our project was done in the INL facilities, but with sorry about that. Sorry, the call was me there. Okay, so there was this facility, the Idaho National Lab and the Department of Homeland Security in the United States did this project where they took this relay that was able to connect remotely, as we talked just earlier about HMIs. Well, in this case, it was a relay, and this was used as a vulnerability because these relays were used all across the United States, and this is what they could do, and I will explain what they did exactly later with connecting to that relay and attacking the system. This is a transformer that generates electricity. It's as big as a yellow school bus and weighs a lot of tons, or pounds. So here, let's see it. It's kind of crazy to see that bounce like that. Remember the size and the weight of it, okay? Yeah, not good, right? Like, this is jumping. Yeah, there you go. Really bad. You have a smoke coming. No good, right? Okay. So what they did is attack this relay. This relay was the one that helped to get in phase within the grid, the power grid. So the power grid is in one phase, and you need to make sure that when you connect the transformer is within that phase. This really helped to get that done. this attack was done with a couple lines of code actually, so it wasn't really hard to attack into it. So what it did is that when the system thought they play with the code, so when they really thought that it was in phase within the power grid, it really wasn't. It was out of phase, but the system thought it was because that's what the attack was. So that created, it's spinning really fast, that created for it to break down. And then we have this other attack. This is Ukrainian power plant. We talked about it earlier. And this was a funny thing. I couldn't find the original video. There is a really funny between quotes, of course, because it's not funny. Yeah, this affects a lot of people in the winter in Ukraine, early 2017, if I remember correctly, 2015, and it wasn't funny at all. But it's funny the reaction of the technicians, the control room, how they're looking at their computer, and these people are just cutting off the power. Like they see their mouse moving like without them touching the mouse, and the mouse is just moving. So that's a funny portion of this video. This was a video done by NATO after the attack. And if I go a little forward, sorry. Let's see if I can go. I guess I can. Here. Let's watch.
Від наших енергодиспетчерів районів. Це було несподіванкою, так як ці частини між собою енергетично не з'єднані. Це щось відбулося незвичайне. Коли ми подивилися на наші комп'ютери, то побачили, що курсори мишок самі рухаються, хаотично рухаються по різних підставах.
Okay, so...
І вони вимикають вимикачі, вимикають лінії, трансформатори. Що робити?
Okay, so I just wanted to show that part explanation from their perspective of view. That's really bad. It's an IT attack in this case because I'm not attacking directly the device on the field. I'm attacking your computer that has control to those devices. So this is another perspective on how to attack an ICS OT system. Okay, so we have ICS versus IT pen testing. So IT pen testing is focused on functionality, integrity, and availability. This is a triad, as I mentioned earlier. The ICS pen testing is focused on safety, uptime, and process reliability. I don't want my plant to explode. I don't want anyone to get hurt. I don't want nothing to happen. That could be really bad. And these are really physical systems that could hurt and kill a lot of people. So I don't want anything like that to happen. I want my systems to be up and running. I don't want anything to happen to them. Once something goes bad, I need to stop all the processes, and that makes me lose money. And then I want the process reliability. I want for it to make sure that I can do what I told it to do. If my potato chips, if my water treatment plant, let's put another example, my water treatment plant is running and my treatment for some reason like a hack and is not reliable, my water is not going to be safe. Do I have process put in there for nothing to be happen? How is my system looking for, in case that happens, for nothing to happen to the people? Difference in approach. So we have limited ability for downtime. ICS system is gonna afford outages, as I mentioned earlier. A lot of money, a lot of people suffering. That's not a possibility. That shouldn't be a possibility. Need for extreme caution in testing to avoid disrupting operations. We need to be really careful, as I mentioned earlier, to test anything in a plant, because that could cause disruptions and it could cause a real attack. I need to be really safe when, as a pen tester, I do something in a ICS plant or system. Use ICS specific protocols like Modbus, which require different presenting techniques. And this is another thing. It's the difference between them. No all communicate the same, no all work the same, so we need to understand that portion. So this is the most makes the most sense, of course. Okay, so ICS pen testing phase. Okay, so we have the main content. We have phase 1. So we have planning and scoping. So we need to define the rules of engagement with the client. We need to consider the safety and systems availability. And then to understand your system, when you give me that you want for me to attack your plan as a pen tester, I need to understand your system really well so nothing happens. And I need to make sure what those rules are normally companies already have rules when they hire pen testers, because that will help the pen tester to understand what they can and what they cannot do. But at the same time, the pen tester by themselves, they need to understand better their plan and what they're going to be doing. And now phase 2. So now we have the reconnaissance. So passive information gathering of IC environments, protocols, use, and network structure. It depends how the pen testing is. I didn't mention this earlier, but pen tester could be an insider pen tester or an outsider pen tester. As the name says, insider, I know the system, I know how things work, so I have information about it. So I already have a base of information that I can use. As an outsider, I have no information, I need to find that information. And the outsider portion is the funniest. Well, not funniest, the coolest in my opinion, because you need to find all the information, but there is just, for your information, there is two kind of pen testers out there. So I need to make sure that I don't be detected. Normally, when you get hired by a company, only the CEO, CISO, only the top people that are not doing the daily jobs in the plant, the ones that will be the first line of knowing that something is happening. Those will be the ones that know. Those that are in the front line, the ones that shouldn't know, because at the same time we need to, when we do these activities, is not only to see how your system is protected, if not how the people will respond, because there is a lot of tactics that we can use to get the information. I could do social engineer, which is another kind of hacking minds, let's call it like that, where psychology, I understand human psychology really well, and I could go to you, I get the information I want by talking to you or doing or dressing in a way or something. I could get somewhere that I shouldn't be, but I got there because I play with you. Or previously I sent you an email that you shouldn't open, of things that you like, or creating a fake scenario. So there's different way to get information. Public information are there, OSINT, open source intelligence. Sorry, too many stands of. But yeah, open source intelligence. I could go to your employees' LinkedIn's and maybe they have a picture of the badge. I could make my own fake badge. I don't know. There is so many ways that you could get this information. Phase 3 is vulnerability identification. Once I have some information, I need to look, maybe using Nmap in a way that wouldn't destroy the plant, because Nmap is really aggressive sometimes if it's not configured correctly, and that could cause an overload and it could make the plant to stop and break. So I need to make sure that that's good and is like I do that correctly. PLC scans, define open ports, services, potential vulnerabilities. Nmap is used in other systems and it could be used for IT. In this case, we need to make sure we target and configure it for an ICS system. Depending on the information we found it, we could find even two. If I know that you use the system because, I don't know, your technician in the field posted a picture that you guys use as Siemens PLC specific, I could get really good information from that picture and I could find any vulnerability that is put out there and I could try and use that vulnerability. Exploitation. Once I know and I have an idea and I have vulnerabilities known for what you have, I will carefully control exploitation, get into your system with those vulnerabilities, and often in a test environment to avoid disrupting live systems. Some pen testers, companies will create a clone of your plant to show that they can do it because it's the safest. As a pen tester, you may sign a contract, or if you do something in the plant that shouldn't have happened, you may need to pay the company whatever the losses are, and those losses, I can tell you, are not cheap. You lose a lot of money with not being able to run the plant, but at the same time, you lose money with anything that you may break. And now phase 5, the phase that not that many people like, is reporting and mitigation. This is one of my ones that I like the most in cybersecurity in general, just because I like, more than reporting, I like the mitigation and consulting and teaching and helping. So once I know, and I know that I was able to attack your plan, I take notes while I did all this. All this is important. From phase 1 to phase 4, in this case, you will be taking notes and how you did it, what you found, what you got, etc. So here you will be writing a detailed report of your findings, focusing on operation and impact and mitigation strategies. This is really well used for cybersecurity teams because they can show how the plans are not secure and why they need more budget. That's real. That happens. So okay. So now activity. I will be in the presentation. Of course, people could have asked me anytime, but here I will double check that no one has any questions. Really, I could walk through you with the activity. I had the time up here, you guys cannot see it, but I've been talking for 35 minutes now. It's almost 36. So I know that's good for me too, because I know that I know that we'll have enough time to do the activity. And I could run with it to you, but I'm going to run really, really fast, okay? Okay, let's go to the activity. Okay, let's go back to the role. Okay, so now we're going to go through activity where we are going to be doing this activity that I like from this guy, Marcel Rixen. He's a German pen tester, and he does really good reports and information on ICS pen testing. He has two really well English courses in a platform for, I forgot right now, sorry, for cybersecurity. This Medium is a website where people can post different posts, and I really like his, and I got that information from his post in Medium from 4 different ones on where he speaks on how to exploring ICS vulnerabilities with Compat, which is a tool. So this is where we're going to be touching the tools that you could use in this specific case of ICS pen testing, and as well we will go into activity. So in this case we need a VM machine going out, but in this case I will be presenting this first. I will be showing the people in the room in the meeting these slides first, because I want to make sure they have a virtual machine down low, and then at the same time they have a Linux Kali Linux installed, because if they don't, that way they can install it, and I can walk with them really fast. When we get to this point, it will be installed, and at this point they will be able to get it running really fast. So Python, okay, let's go back. Python 3 and pip installed to the VM, common install in the VM, and basic knowledge of the terminal commands. And I will be walking through you guys over this here in a minute on these last three. And for this last third one, I mean, I could help you guys if you guys have any questions. So setting up your environment, okay? So we open Kali Linux through our virtual machine. I will be opening Kali Linux, logging in, and then opening a terminal our Linux virtual machine. We'll be installing Python 3. If you guys don't know if you have it or not, I would recommend you guys to do sudo apt-get install Python 3. If you guys had it, it will show you guys. It will try to upgrade it if you guys if it's not upgraded yet, then we will be installing pip for Python 3. You guys have the command right here, and then at the same time we will be installing Compat, which is the tool we're using for this activity, which it will be doing pip install Compat. Then we will be disabling our uncomplicated firewall, doing this command right here, and then we will be updating our path. So in this case, we'll be sudo nano to our profile. This will depend on whatever, and then we'll be doing the next commands. Okay. So we will be doing Compat with the full template. This is how you can get it there, and then verify Compat is running, and you should be able to see a log message indicating that the Compat is running and operational. Okay, so scanning open ports with Mmap. We have done this before in the past in other club meetings, but just for those that haven't, we'll be having a Compat IP that we got. So in a new terminal, I will be running this command with IP that we got from there. And then if you see anything like this, that will be really interesting, because those are the ports that we saw earlier. And some systems will have to have this open. And of course, in this case, we already have gone through so many stuff in our in our point right here that for the most part we are just doing phase 3, phase 4, and for the most part phase 4. We got through the system, we got there. A majority of the system, I would say, they will need to have this open because there has to be communication between the control systems and the field devices within the engineer workstations. So the dashboard will be open, but those could be used by us because some of these ports and services are not secure, they are not encrypted. So okay, so explaining service with mmap version detection. So we'll be doing mmap version detection. I will be putting the IP right here for compot, and then look for services versions. This will help us to get the versions and understand better what we'll be looking for vulnerabilities. Just make note that compot may simulate incorrect services names. Then we'll be going through capturing and analyzing traffic with Wireshark. Wireshark is a powerful tool. We used it in the past, and it will help us to collect packages and understand better what communications are going between our system. And once we get somewhere in a system as an engineer workstation, we could run this and see what is going on. So we'll be starting capture packages in there, and as well we will be applying this filter. This will be focusing on modbus traffic. And once we have run it for a couple minutes, we could let it, we could stop it, and we could analyze the traffic. Okay, so now we're going to use SMMP for reconnaissance. But if I don't say the word correctly, it's a really hard word for me. I'm working on it, but it's reconnaissance. So again, I'm sorry if I don't say it correctly, but we'll be installing SMP check tool. If you don't have it already installed, again, you can just put this in you if you're not sure, and then it will in case if it's already downloaded, it will just update. So it's always good to run it. And then run SMP check on port 1600 UDP. You will be doing this with the compop IP. That one right there is SMP. And then analyze the output, review the information that you retrieve from that, and then let's see what information you have from configurations and network statics. There is out of code information that will be found in here. Then interacting with the ISC 104 protocol. So we will be assigning the compot with the IEC 104 template. We'll be using this right here. Then scan for open ports. Define the IEC 100 port. Duplicate this one, and then a mmap right here. And then exploring with Metasploit. Metasploit is a very well-known tool used for pen testing, hacking, ethical hacking, etc. So you will be open Metasploit. We'll be loading the IEC 104 client module, and then set required parameters. We'll be doing these commands right here, and then we will run the interpretation command. And thank you so much. I will be asking for questions, of course. I will be moving between slide to slide, showing them like a slide to my VM machine, showing them in the moment too. And if I have any question, they can see how I can fix that from my perspective. That way, everybody can see. I will be asking for questions in the end, thanking them, and that was everything. Almost an hour right there, so that's good. Outside that, I don't think I missed anything. I will say too that for those that are interested, they have the link right here. I will be posting this later on in our Discord server that we use for our community. I will be showing them this portion right here in the bottom right. We're just learning OT cybersecurity with Compot, and that will take us here directly, but this is the guy that did the activity that I used. He has a really cool post. I read every one of them. It's really cool guy. As I say, he has activities that he has in Udemy, I think it is. I cannot see it right now. But yeah, no, this is a really cool guy if you guys are interested about it. So yeah, thank you so much for listening. I guess, muchas gracias por escucharme. Ya puedo volver al español. Espero que os haya gustado. Dejarme cualquier cosa que creáis que puedo mejorar en mi comunicación, obviamente. Y nada, muchas gracias por todo. Espero que tengáis un buen día. Espero que hayáis aprendido algo nuevo si no conocíais este tema de la ciberseguridad industrial. Así que nada, muchas gracias. Espero que tengáis un gran día. Y nada, fin de semana. Un beso, hasta luego.